Oh, hello there. I'm glad you're here. I have a very important question for you. Why is this pig so weird looking? I mean, the pieces are all there. It's got 2 eyes, a mouth, a nose, 2 ears. But come on, look at this thing. I mean, gosh, it's like its eyes are on its nose or something. Peppa Pig is kind of reminiscent of Pablo Picasso in his Cubist art. You see, in Cubism, you take different perspectives of the same subject and you kind of put them all together to give it a strange, holistic view of the object, but from one single angle. We have the angles that we're used to seeing things from, our usual perspective, but then there's the perspective of other people. For example, this is the perspective that my daughter usually sees me from. Poor girl. And I still remember the first time I saw a photograph of myself taken from profile. This way that we see things is known as perspective, and it has some surprising limitations. Here's another question for you. Why do objects in a rearview mirror appear to be farther away than they actually are? And is that the case for every mirror? Well, no, that doesn't seem to be the case. And you can see this for yourself. If you put your hand up to a mirror, you'll see that the hand in the mirror is about the same size as your hand. And as you move your hand away, the hand in the mirror seems to get smaller, but it gets smaller at the same rate that a real hand would. So what's going on with that car rear view mirror? Well, the rear view mirror in your car is actually slightly convex, like the backside of a spoon. What that means is that it is a little bit farther out in the middle than it is on the edges. And what that does is it gives you a wider view, so you can see more behind you when you look in it. Because it makes your field of vision larger, that means that the objects in that field of vision take up a smaller percentage of it, and our brain interprets that as being farther away. When you look at any object, the light bouncing off of it enters into your eye through your pupil, and it's focused by the lens onto the back of your eye. And it's going to take up a certain percentage of your eye. We call this the angle of viewing here. That's why objects look smaller the farther away they are, because they take up a smaller and smaller percentage of our field of vision. The angle gets smaller. And that's why objects look really big when they're super close up. Now, our brain doesn't really have any way of knowing whether an object is really big or just really close, other than context clues. The context is all the surrounding stuff. Does everything look small in comparison? Does everything look big in comparison? And as you can see here, if your object is much closer to the eye, it's going to take up a bigger percentage. It will have a larger angle. In addition to having a limited grasp of the actual size of different objects and their distance away from us, and only being able to see one angle of something at a time, we're also limited in the way that we're able to perceive the colors of objects. For example, this is a colorblind test. If you have normal vision, you'll be able to clearly see the number 7 in this circle. You'll be able to see the number 6 in this circle, and you'll be able to see the number 26 in this circle. However, if you're colorblind, you won't be able to see those numbers. And there's not just one type of color blindness, there are actually a few. For this reason, different people could be looking at the same thing and be seeing different colors. And of course, that doesn't even touch on the colors that no human is able to see, such as infrared and ultraviolet, which some species in the animal kingdom are actually able to see. And even the colors that we think we can see are going to be impacted by the lighting in the room, like how much light there is, or shadow, or even the shade of the light that we're using to see by. Just like with size or distance, our brain has to rely on clues from the things around us in order to make a judgment and interpret those light waves that are interacting with our eyeballs to decide what it is we're actually looking at. Sometimes that can lead to confusion, like in 2015 when this dress went viral because people couldn't decide whether it was white and gold or blue and black. Supposedly the actual dress was blue and black, but I don't know. So what does all of this mean? What do we do with this? Can we actually really know anything at all? We are all finite beings living in an infinite universe. It's impossible for us to know everything. And it's always possible that we'll learn something that could change everything. But the more that we do learn, the more perspectives we have to draw from. And we can put those multiple perspectives together to gain a better understanding of what is true. Thanks for watching.